a Kenwood Chef Classic. So this belongs to a friend of a friend. And I was visiting his workshop and I seen it sat in the corner and I said, oh, what's the matter with that? And he says, well, I was going to look at it 3 years ago for my wife, but I just never got around to it. I says, oh, well, we'll power it up and see what it does. And he showed us what it does. So I says, well, I'll take it away and I'll see if I can repair it. So I'll show you what it's doing. I'll just get some power and we'll plug it in. So it's got power now. I'll just try and hold it up a bit so you can see what's going on. And if I switch it on, it does that, and it doesn't matter what speed you put it on. And it just progressively gets slower and slower until it just stops. So I don't know whether it's a mechanical problem, whether there's some grease or something dried up in here, or if it's an electrical problem. But I'm sure we'll find out. So I'm just going to unplug it, and then we'll try and figure out how it comes apart. Oh, I can see a couple of screws here. And I think this front part comes off, which I don't think really helps a lot. It just gives access to a little port there that you can plug attachments onto. I'm just going to stand it up a second. Oh, we've got some screws here. Anyway, I'll try removing those. Let's grab a screwdriver. I'll grab a different screwdriver. Let's put that bit to one side. Let's get this plate out of the way. Well, that was fairly straightforward. Well, that's the top of it off. Right, now we can see the motor. It does feel a little bit tight to turn that. I'm just going to take the whisk thing off a sec here. Let's get that out of the way. I think I might just try and pop this belt off. We'll just see what the motor does then. Just to see if it's a problem within the gearbox maybe, or if it's a problem with the motor, or if it's a problem with something else. Right, that's the belt off. Right, I'm just going to plug it back in and let's see what it's doing now. Well, it's just gone a bit nuts there now. And now it's stopped completely. Interesting. So I don't, and that's turning nice and freely. And the motor appears to turn nice and freely as well. So I wonder if it's a problem with the speed controller. So how do we get into that then? I can see one screw at the bottom there, so I'll try taking that one out. Now I'm just going to unplug it from the mains first before I forget. That just gives me access to a small connector block. I don't think there's anything else underneath there. Let's see if we can open this bit up. Oh, that was a bit severe. Right, I can see a couple of screws down there, so I'm going to remove those and we'll see if we can get this bottom part off. Maybe get into this black cover here. Right, get that bit out of the way. See if I can get this. Right, I can unplug the power lead here. Let's see if we can get that out of the way. There we go. And this looks like the speed controller here. Let's see if we can get into that. Right, I'm just going to get this bit out of the way then, and we'll have a look in this speed controller. And it looks like it's clipped together there. Tell you what, I'll just zoom down a bit so I can get a bit closer look. I'll just grab a small screwdriver and try and get into that. There we go. Right, what have we got in here then? Does this little board come out? Yes. So it looks like that just turns this potentiometer here. It looks like we've got a set potentiometer there. Zener diode. A couple of resistors, another diode there. There's a triac here. What have we got on the back? Looks like there's an IC there. Let's zoom down a bit, see if we can see what number that IC is. That's actually a PIC microcontroller. It looks like a PIC 16C. Is it 345 that? I can't quite tell for the writing on it. Let's just see if we can clean that off a bit. So a little computer in a mixer, eh? I think that was 16C 505. Yeah, it looks like 505 that. So why isn't it working? Right, so let's just have a look. We've got the power comes in here. I think it was at the motor connection. I'm just going to have a quick look again, just to see what wires were what. No, the power comes in on these pins here. Right, so it comes in here. It looks like it goes through a capacitor. And that's the on-off switch. I'm just trying to work out what's going on here. So, alright, okay. So power comes in on this pin as well. Goes through the on-off switch. Yeah, goes from there through the on-off switch to this point here, which is to the motor. And this must be the one that regulates the speed, which is controlled by this triac up here by the look of things. Yeah. So I guess this is a capacitive dropper, which then goes through a resistor, through another resistor by the look of things. Yeah. And then we've got a diode, which must be the rectifier, and then probably ends up on this capacitor here. And that's probably what's powering the microcontroller. Now I'll just zoom out a fraction. So initial thoughts are possibly a faulty triac, faulty capacitor, a faulty capacitive dropper, because it does seem to power up and then get gradually worse, a bit like, you know, like the kind of symptoms you would get with a capacitor. And that's it, BTA 216-600B. Now I don't think I've got one of those. I do have some other triacs, but I'm just wondering if it's that capacitive dropper. What do we do? Do we take the triac out first or the capacitive dropper? Let's see if we can measure anything in circuit, I think, first. We'll probably not be able to do that, but let's give it a go. I'll just zoom out and we'll get the meter on it. I'm just going to see if we get any readings. Because I did a bread maker recently. Yeah, I think we're measuring the resistor across there. And there was some weird readings we were getting across two of the pins. I don't seem to be getting any odd readings between these two. Let's go on to capacitance. We'll just see. Now what's that reading? I'll just zoom down a bit so I can see. Is that 15 microfarad? Or 0.15 microfarad? Let's just try and clean that up a little bit. 0.15 microfarad. Actually, you can't see the meter there. Let's just zoom out a bit. 390 nanofarads. I don't think that's right. Let's pull this capacitor. Let's try to pull this capacitor. There we go. Let's see what this measures now. 150 nanofarads. So I think that's actually measuring okay. I thought it might have been that. Right, I've just been to have a look and I've actually got some of those capacitors. So I might change it in any case, even though it's measuring okay. I mean, yeah, it's pretty much the same, that one. So I don't think it's the capacitor. So what else have we got? Electrolytic or triac, possibly? Let's just swap this capacitor over. We'll just have a look and see if that makes any difference. I don't think it is, but I see it seems to measure okay. Let's use a bit solder braid. Just going to put a bit of flux on that. Just trim those legs off. What's this electrolytic? It is 220 at 16 volts. Let's see what that measures. Yeah, close enough. So the only other thing we left on this is this triac. So we'll just quickly try it with the capacitor changed and we'll see what it does. And if it's still the same, I think the next thing is going to be have a look at that triac. Right, let's go and get the rest of it a second. Zoom out a fraction. Let's try and get these wires plugged in. Let's plug the power lead in and see what it does. And pretty much the same. Right, let's just unplug that again. Let's move this bit out of the way. I mean, the only other thing I could think would be the brushes possibly on the motor. If the brushes have worn down perhaps and are arcing, but it didn't look like there was any sparks or anything from the motor. I do have a Zener diode there. That must be for the regulation of the supply to the microcontroller, I guess. Let's just try a diode check. That seems okay. Let's see what drives this triac. I just wonder if it's one of these little transistors or something. So, looks like it comes to here. which is marked R11. And then goes through to here. And then it just looks like it goes straight into the microcontroller. I don't think it would be a dirty potentiometer or anything here, like a dirty speed control. But I can't see anything obvious on this up to now. I just notice there's a little bit of a mark on that resistor, but let's just check this one. You can't actually see the meter there. Let's just check that again. Yeah, 4.7. Pretty much 4.7, so the resistors are okay. So I'm just wondering if the problem is on here or if it is something to do with the motor. It just seems a bit strange how it seems to power up and then it seems to kind of flutter and stop. So I would have thought if it had been the motor, it would have done that continuously. I've just thought of an idea how we can check to see if it is the motor or not. If we just link the triac pins together here, so it sends full power to the motor, and then we can see what that does. I mean, that would be an option, and then at least we'll know if it's the motor or if it's a problem on the board. Right, I'll just get a little bit wire a second, and a bit solder. Just tin this wire up. Right, so that should just send power straight to the motor and bypass the speed control. So let's see what that does. And then at least it's ruling out the motor. Right, I'll zoom back out a sec. And we'll just hook this back up. And hopefully it doesn't explode all over my bench. Right, let's make sure it's switched off first. Right. Right, so I think we can rule out the motor. Let's just try that with the belt back on. I'm just curious. Let's see if we can get this belt back on. There we go. Just want to see if the rest of it works okay. And if this works okay, then obviously the fault must be to do with the speed controller. Right, let's give this a go. Right. So we know the motor's okay, we know the gearbox is okay, must be a problem with the speed controller. Right, let's have another look at that then. Let's just unplug it first. I'm just going to remove that wire link. Right, what else have we got on this board then? So we've got a small microcontroller, we've got a couple of transistors, and a triac pretty much. We know it's not the dropback capacitor because we've replaced that, so we've ruled that out. This capacitor seems to measure okay. There's another capacitor there, but that just looks like a decoupler or something across the microcontroller. I mean, there's not a lot on this circuit, but it's trying to find out what's actually gone on it. I mean, I could try powering it up and then we could measure the voltage across this Zener diode just to see if it fluctuates or whatever. Or is it the triac breaking down under load? I mean, it's possible. BTA 216600B. I'll have a look at the specs of that Triac and I'll see if I've got any equivalents or if I've got one of those. I don't think I have, but I'll see what I can find. Right, one moment please. Right, unfortunately I don't have one of those Triacs. The only one I've got on hand is a BTA-08600B. Now I've had a look at the wattage of the mixer and it's 800 watts. So that works out about 4 amps. And this is a 16 amp Triac that's in here and this is an 8 amp one. So in theory this Triac should be enough to make the mixer work. So I may try that, but first I just want to double check that we're getting 5 volts to the microcontroller and that and stuff. So I've unplugged the lead from the mixer here. I've just pulled the cable grip thing through. So I'm going to plug it in and then I'm going to plug it into the mains. I just want to carefully measure across this Zener diode here, so let's have a look. So we've got 5 volts there and it seems nice and stable. And I was just thinking about the other transistors and stuff on the back of this and what they may be for. And the way this circuit probably works is it needs to find out when the mains crosses what's called the zero cross. So the AC wave goes up, then it goes to 0, and then it goes negative, and then goes to 0. And what it'll be doing, it'll be turning the Triac on at a certain point during that wave, usually near towards the end of the wave. So if we've got the top half going like that, it'll be turning on, let's say round about there, or round about near the end of that peak, and the same on the bottom. So it needs to synchronise with the mains to be able to do that. So that's what it's probably using these 2 transistors for. It's probably using one of them to sense the mains voltage. Well, that's what I think anyway. So I think I'll pop that Triac out and we'll just try it with the 08 one that I've got. I mean, obviously if it does work I'll get the proper one, but this is just to rule it out basically. So let's see where it is. It's just about here. So I'll just zoom down a bit. I'm just going to put some fresh solder on first. Right, let's grab the solder set. This little button bolt here, so just undo that. Right, there we go. Let's have to bend the legs in a similar fashion. We'll just solder that up. Right, I'll go and get the rest of it then. And we'll see if that's made any difference. Right, let's see what it does now then. Still the same. So, doesn't appear to be the Triac then. Let's turn on a little bit of a head scratcher, this one. And we do have a couple of other connections on this motor here, which I'm not sure what they're for. Let's have another look at the speed controller again. I did have a few comments of people saying, you know, they're quite impressed with how quick I can diagnose problems. Well, sometimes you do get ones like this. I mean, the motor didn't seem to be struggling when we give it full power. There is this connector here which seems to go somewhere into the motor. I mean, I wouldn't have thought that would be, unless that's some kind of feedback for speed or something, like some kind of speed sensor on the motor perhaps. I mean, I think I could think, unless one of these little transistors have failed, or partially failed. I'm not sure if you can open this potentiometer to try and get a bit switch cleaner in it or something. That's the only other thing I could think. But I don't think it's that, because even when it's on full, the speed doesn't seem to run properly. I'm just not sure why there's 5 connections on this potentiometer as well. I don't know what the bottom 2 are for. Because those seem to go to that connector over here as well. And this is just a link straight through perhaps. I mean, it's got a like a metal thing either side here, so it's just a mounting clip. Let's just see if there's continuity across there. Let's get the meter in shot. Yeah, it just looks like a straight through. Just a mountain lug or something that. I think the next thing might be to inspect some of these little surface mount components then. I've just seen that capacitor there, but it's just across the supply. Yeah, because it goes to there and it goes to there, which, yeah. So that capacitor's just a smoothing cap across the supply, so. Let's just pull that. I just want to check it with the component tester. It seems to measure okay when I tried it with the test meter, but you never know. Let's get the component tester. Yeah, that seems fine. So it's not that. I'll just solder that back up. So just have a look at those little transistors, see if we can see any markings on them. Well, that's a 1AM. This one just here. And I've definitely got some of those because they're quite common. I'm not sure about the other one, the 2A. I can't see any dry joints or anything on this. So the triax driven from that pin there. But we've got these. Ah, so hold on. Unless one detects the positive phase of the mains and one detects the negative phase of the mains, possibly. That might be the way it works, because that's the base, that's the emitter, and that's the collector, which seems to go to the input of this pin here, and this one, the collector seems to go to that pin there. So I think that's how it measures what phase, or what position of the phase that the main supply is. So it could be something to do with that, maybe. Right, well, I've had a look around in my little spares boxes and I've got both of those transistors, Well, they actually seem to measure okay. I mean, if I just do this one, that seems to measure okay. And that one seems to measure okay. So I'm not sure whether just to change them, just to rule them out. There's not really much else on this board. I mean, all the resistors look okay, they don't appear scorched or anything. And it seems like it's sort of breaking down under load. Let's swap these two transistors, let's see if that makes any difference. Right, let's put some flux on. That's kind of glued on. I thought I heard the board swell up a bit there. That's not good. I might just use the iron to try and get this one off then. I'll put some fresh solder on here while I'm on. Right, so there's the replacement 1AM. Let's try and get a bit of flux on that. I normally use hot air for this, but by the way the board bubbled up, I'm not that keen on doing it. Right, I'm just going to spin this around. It'll be easier to do the other one. Just to get a slightly better view of it, that's all. Right, I think that'll do. I'm just going to add a little bit of flux on that, just I'm not quite happy with those two legs on there. Yeah, I think I'm happy with that. Right, let's see if I can put this back together now and try it again. Right, let's see what it does now then. Still exactly the same. But that's just strange, isn't it? Because when you first start it up, it's like if we leave it. No, thought I heard it make a noise there. It's like if we leave it for a while, and then try it, it'll start and then slow down. So if we try it now, let's say. What does pulse do? Same sort of thing. So it kind of starts up for a second, but then sort of dies off. It's got pretty much scratching my head, this one. Why would it be doing that? And if we supply power to the motor directly, it runs at full speed. I'm going to have a look to see what these other wires go to on the motor. I'm just wondering if it's some kind of thermal cutout that's gone wrong, possibly. That's it, it's only that thing I could think. Like if there's a thermal sensor, I don't think the motor's getting warm or anything, I don't know. Right, let's have a look at that. I was pretty sure it's the speed controller though, but without another one to test, we're pretty much just kind of guessing. How does this motor come apart now then? So it looks like we undo those here and it comes out the bottom. Let's remove this belt again. And the weird thing is it does it with the motor being not under load as well. I might need a bigger torque. So does this one fit? This one fits. I'm just going to make a mark on this motor so I know which way around it goes. Just like that. Does this one come out the bottom? Yes. Nice. Well, if I disconnect this bit as well, it might be easier to test this. Well, I was saying that the motor might jump around on the bench like, so I don't know whether I want to do that. I'll just move this bit out of the way for now. Right, how does this come apart then? Let's say we've got some clips here. Now I'm just going to make a mark on this as well so I know which way it goes. And I'll make a mark on the actual motor as well. Well, I can see two blue wires, two thin blue wires come up to something just down here in the motor. I don't know what that is. Is that a coil or a sensor? It's hard to tell whether that's another coil. I mean, there's the brushes on the motor. I'll just find something to point with here. There's the brushes there, and they've got plenty of carbon still on them. I mean, it looks pretty much brand new, this motor. They've only got a tiny little bit of wear on them. Let's have a look at the other one, on the other side. There it is there, and it's right at the back as well. Yeah, you can see there's plenty of carbon on it. I don't know, that's a little thermal cutout or something, or a thermal fuse, just in that part there. I can see a wire going to it and coming back out. Could be a thermal fuse, possibly. So what do the two white wires do? Because I can't see them. Looks a bit of a nightmare to remove this part as well. You see the two white wires disappear down there. I think I might have to take that off just to have a look. Let's see if I can figure out how we can get this off. That's actually coming off not so bad. I thought it would be a nightmare to get this off. Well, that was fairly straightforward. But that part doesn't want to come off. Right, I'll see if I can get this part off. One moment please. Right, so after much persuasion, I managed to get that off. And it looks like we've got a speed sensor down here. I've just noticed there's a magnet around the outside here. Which seems a bit loose as well, actually. I think that's a magnet. Yeah, there's like a silicone washer, and then that looks like a magnet underneath. And that looks like some kind of magnetic pickup there, like a Hall effect sensor. Right, can we get this part off? Let's have a look. Turned into a bit of a nightmare, this one. There we go. So they're two with the power for the motor. And then we've got this one here, which I'm not sure what that is, whether it's a coil or whether it's a temperature sensor. And then we've got this one here, which is a speed sensor. The two white ones. Almost looks like a little reed switch. Right, let's see if we get any reading on that. Let's go into resistance. And it's the two little white wires, isn't it? So if we go on to here. Oh, I'm getting a reading on it. It seems a fairly consistent reading. We do get a small pulse when we turn it. I still don't know whether that's right or not. Let's go on to it is giving something out there, but whether or not it's right or not, I don't know. But I would have thought that magnet shouldn't be able to spin like it's doing there. It just seems a bit odd. Just doesn't quite make sense, that. Right, I'm just going to have a little bit of investigation, see if I can figure out if there's anything online about these motors or anything. Well, I still wasn't getting very far with this, so I thought I'd leave it until the following day because it was getting quite late. And the only thing I've done so far is had a look at this little device down here. I'll just zoom down a bit so you can see. And it's just a little inductor. I did scrape a little bit of the heat shrink away, and it's just a little coil there which obviously picks up the magnetism from this magnet that goes around on this part here, which it must use to get feedback of the speed of rotation here. And this thing here does look like a temperature sensor. I'll just zoom out a fraction. If we just poke the leads in here on resistance, we're getting about 127k. I'll just bring the soldering iron next to this, just to try and get a little bit of heat there. There you go, you can see it changing. You see it change off the heat off the soldering iron. And then it's just start going back up in a moment. There we go. So that's working, and I think the sensor's working because it's just literally a little inductor. Now the only thing I did see online is there were some of these replacement magnets, but I still don't think that that's the problem. I still think it's a problem on the speed control board. So I don't know whether to get this under the microscope or not, just to check some of these surface mount resistors and things, because even zoomed in fully it's still quite hard to see them. So I'll get the microscope out and we'll just have a look over this board just to see if we can see anything obvious, but I'm kind of scratching my head with this one so far. So that's the microcontroller, and that's one of the transistors that are replaced here. Now there might possibly be a little bit of a dry joint there, and maybe a little bit of a dry joint just on this resistor here. I'm just wondering if one of these resistors have gone open circuit or something. That's the only thing I can really think now, because I mean we've checked just about everything else. And there's not really a lot on this board. I mean, it's pretty much just a microcontroller and just a couple of drop down resistors and a capacitor. That's roughly about it. Let's just try touching up these resistors here, just in case there's anything to do with that. Let's get a bit of flux on there. Focus that in a little bit better. Not sure if it's worth touching up some of these other ones while I'm here. It's not going to hurt. Well, I think that's about it really. I can't see any dry joints on the main IC itself. No, looks okay. It just sometimes shows up like it's a bit of a dry joint depending on the angle of the light. We'll just do it anyway, might as well. Right, I think we'll give that a try, see if that's made any difference. Right, this is already switched on, so let's see what happens when we plug it in. Let's see what this does. That's just weird, that. I mean, it's still on at the moment. I don't know if that was me. That's interesting. If I poke that side of the resistor there, you seems to do something. If we just touch that resistor. I'm just going to switch it off a sec, we'll just see where that resistor goes. So that was that resistor there. So I'll just zoom down a bit. So R10. So that comes in from the mains. And then it goes over to that transistor I replaced. Well, that's one of the ones that I wasn't sure whether it's some kind of zero crossing detector. So it seems to be from here. Yeah, because it was when I was touching there. That's when it seemed to spring into life, but not so much on this side of it. I don't know if that can zoom down anymore with this. There we go. So that seems to come down here through these resistors and through these transistors to here. I wonder if that resistor's okay, because that comes in from the mains. Let's take this resistor out and have a look. I'm not sure what value that is. Right, let's pop it out and see if we can measure it. Well, I don't seem to be getting a reading on it. Looks open circuit, that. Right, so I'll just go and see if I can work out what colour or what value that is. So it's one of these 5-band colours, isn't it? It looks like brown. It looks like brown, orange, black, purple, yellow. So what's that? 1, 3. So what's that? 1, 3, 0. Purple 7. So yeah, it looks like it might be quite a high resistance, that one. I'll just look that up just to check that I'm reading that properly. Right, so I'm not sure whether I was reading this resistor from the wrong end. If you start at this end, it works out at 1.3 gig ohms, which seems quite high. Or if you read it the other way, it should be 470k. So this resistor here has actually got the same markings on it. So I've just pulled this one just to see. And we'll get 500k or 502k. So that might well be right, because it has got a brown for the tolerance. So, and this one, which has got the same markings on it, measures open circuit. And that might mean when we were touching this, it was sending interference to the microcontroller, which should have been picking up the mains frequency, and that's why it wasn't regulating the speed. So I'm going to see if I've got a resistor suitable to replace this one, and then we'll fit it and then we'll see what it does. So hopefully that's going to be it. Right, back, and I found some suitable resistors. Right, so let's pull this other one out. Let's clean that hole up a bit. Right, let's put the new resistors in. Well, this has been a bit of a nightmare, this one. I'll tell you what, I'll just get this back in its case here first. And I'll be swapping the triac back over for the original one. Right, let's connect this back up. May have to put the cover back on this just to keep it together. Power lead. Yes! Thank God for that. Right, I shall start putting this back together. I'll swap that triac back first and then I'll start assembling this and then we'll give it a final test, I think. So I've just had a bit of a nightmare with this motor because I put that part back on, but you've got to put the white part on before you put this part on. So I sort of try and get this part back off and then put the white bit back on. So that was a bit of a nightmare. And I've just swapped the triac over. I've took the BTA 08 out that I'd put in previously and put the original triac back in because that one's rated at 16 amp and this one's only rated at 8. So right, I think I'll crack on assembling it and we'll come back to it once it's all assembled. So just before I show you it working, I thought we'd just have a quick look at these two resistors under the microscope just to see if we could see any, just in case I'd missed anything. But that's one of the resistors there and that one looks fine. And this is the other resistor here. So if I just get the test meter, I'll just do this top resistor first. I'll try to. There we go. And if I get the other resistor in shot, and that one's open circuit. So that's the failed one. Yeah, it looks perfect. So I don't think I've really had that before. Like I say, normally they go either discoloured or you can see burning on them or whatever, but I don't think I've had one fail like that before. Right then, let's get this mixer on the bench then and see if it all works. Right, I'm just going to plug it in. I just might have to tilt it a little bit. And we've got a pulse function there as well. Right, so I think we'll call this one fixed then, but it was a bit of a nightmare, that. A bit of a kitchen nightmare. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.